Okay, so after you get the period of pi, you have to divide it into fourths so you know how to count. But then we need to figure out from my starting point, I got to add pi over 4. So I have negative 2 pi over 3, and I got to add pi over 4. That's so fun. So common denominators, 12 times by 4 over 4. This is negative 8. Plus, that'd be 12 times by 3 over 3, 3 pi. So what's my next point going to be? I know, it's easier on your calculator, huh? Negative 5 pi over 12, and I'm going by about pi over 4. Let's see what the next one is, too. All right, so then I have negative 5 pi over 12, and I'm going to add another 3 pi over 12, or pi over 4. That's negative 2 pi over 12, right? And then I have another one, negative 2 pi over 12, and I'm adding another 3 pi over 12, which is pi over 12. What would be a good way to actually scale this? Nobody knows. So we're starting here, and then we've got all these points, right? We're going to have to do one more, but that's where we're starting. This is the same as this guy, negative 8 pi over 12, negative 5 pi over 12, negative 2 pi over 12, positive pi over 12. If you really wanted to scale it accurately, it would be nice to go by pi over 12s, all right? But I'm not going to exactly do that. I'm just going to estimate, okay? So these are good places to put some points because I can actually kind of see. So this is going to be my positive pi over 12, and then this has to go like twice as much in the negative direction, so negative 2 pi over 12. And then I need a negative 5 pi over 12. And a negative 8 pi over 12. And we got to go one more. I got to add 3 pi over 12. So that's 4 pi over 12. Okay, so I had to shift that quite a bit more to the left than I initially thought, right? So now I am going to do my points. It is a sine graph, and we are starting right, or it's a cosine graph. We are starting right here at the top because it's positive. Then I'm coming down to the middle, and then I'm going to go down to the bottom, and then back up to my green line, and then back up here to the top. And we get this beautiful graph of a mess. But there you go. Okay. Let's try one more. We're going to do the whiteboards at the end, okay? All right, so I have y equals negative 6 sine, and what do I need to do first? Yeah, factor out the 1/2. So if I take out a 1/2, what would this be? Yeah, pi over 2, because I have to be able to multiply back to get pi over 4. Yeah. Yeah. All right, so here's my line. We'll draw our x, or our y-axis here. And we're going to shift it first up 1 because of that plus 1. And then I'm going to go ahead and I'm going to add 6 and subtract 6. I'm just going to estimate that because I don't have a lot of space here. So this goes up 1. And then if I add 6, what am I up at now? 7. And if I'm at 1 and I subtract 6, this is going to be at negative 5. Okay. And then my starting point is what? Yeah, we're going to go right pi over 2 because it was negative, so now I move positive pi over 2. So I'm going to move to the right pi over 2. I guess I'll label it down here because maybe I'll actually be able to see what I'm doing. And my period is going to be 2 pi divided by b. And what is b in this case? It is 1/2, so I flip and multiply. That gives me 4 pi. This one's nice. Then I divide it by 4 to get my intervals, right? So 4 pi divided by 4 means each interval goes by pi. So I might want to scoot this one over just a tad so I have enough space. Like I'm going to actually make this a little closer. Pi over 2, and then I'm going to add pi. So if this is pi over 2, I need to make that distance twice as much, right? I'm going to add 1, 2, 3, 4. All right, so if I add 2 pi over 2, what is this going to be? And then I add another 2 pi over 2. 5 pi over 2, add another 2 pi over 2, 7 pi over 2, and 9 pi over 2. Okay, so this one is sine. And so I'm going to start here on the green line. That's the middle. And it's a negative sign, so I have to go down first. So on this point, I'm going to be down here, and then back up to my center green line, and then up, and then back to my center line. And this gives me one full negative sine graph. Whoa, missed. I feel like we're getting better. We'll come back to that. Now for some new stuff. Oh, did I go too fast? Oh, factor tractor with trigonometry. So we're always looking for our 3 Pythagorean best friends. So let's write down them again because you need to know these. The only one you need to memorize is this one. Sine squared x plus cosine squared x equals 1. Everyone write these down somewhere on your paper. Now we divide everything by sine squared. So Tyler, if I divide sine squared by sine squared, what do I get? Good. And Maddie, if I divide cosine squared by sine squared, what do I get? Good. And Anna, if I divide 1 by sine squared, what do I get? Oh, good. There's 2 of you. Okay. And now I'm going to divide through by cosine squared. So Thomas D, what do I get when I divide through by cosine squared? What's this divided by cosine squared? What's sine squared divided by cosine squared? There we go. Tangent squared x. All right. And Devin, what's cosine squared divided by cosine squared? And now we have 1 divided by cosine squared, which is secant squared. Yes. Okay. So you got to know those. You're always kind of looking for those, right? That's what we're looking to get. So first of all, if I have sine cubed, well, we could write this as sine x times sine squared x. How does this help? We could replace the sine squared with something, okay? So just, you could factor out sine squared. This guy right here is to the 4th power. So none of these are to the 4th power, but I can factor it because it's a perfect difference of squares. So this factors cosecant squared, that's like an alpha sign, plus cotangent squared. I think it looks like that. Okay, and then cosecant squared minus cotangent squared. Okay, it's the 4th power. There's a minus in the middle, so it's a plus minus of the same thing, and it goes down to squares. How does this help us? Well, one of these is special. This one right here is equal to what? 1, if you move this over, okay? Now, tangent squared theta minus 1. Is that one of these lovely identities? Bow, bow. It is not. Okay? Because it's a minus. Tangent squared plus 1 is 1. There's no way to make this happen. Even if you move stuff around, you can't get that. All right? So we actually do want to factor 1 like this. This factors tangent theta plus 1 times tangent theta minus 1. It's just a difference of squares. Okay? This one also factors, I have sine to the 4th, and I have a 1. So this one we're just going to like unfoil it. So think of it like this. These first 2 spots would have to multiply to be a 1. So what multiplies to be 1? 1 times 1. Boom. Okay? These next 2 spots have to multiply to be a positive sine to the 4th x. So we could put a sine squared x times a sine squared x. Could be a positive times a positive, or it could be a negative times a negative. How do I know? My middle terms, this would be a sine squared x and a sine squared x, have to add to be negative 2 sine squared x. So they both have to be negative. Okay. All right, now I've got 1 minus tangent squared theta. Is there any way to get that out of this? Can we get one of our Pythagoreans? Nope. So we factor tractor this one. 1 plus tangent theta, 1 minus tangent theta. Just like the other one, only in the other order. All right, we've got the cubes. Do you guys remember the cubes? Remember when we did a cubed plus b cubed? We factor tractored this. A plus b times a squared minus ab plus b squared. This is what we're doing with trig functions. It's not very hard. This is not hard. So you guys, it's sine beta plus cosine beta. That's that capital B. So all I'm doing is this formula. So the first one's just plus. Then I do the first thing squared. So what goes here? Good, sine squared beta. And then I have a minus sign, and I multiply them together. So I multiply this times this. So it's a sine beta cosine beta. And then a plus the second thing squared. So it's a cosine squared beta. That's just the cubes formula using sine and cosine instead of a and b. Okay. And this last one, if we were to factor tractor this, just look for a GCF. You can always look for a GCF. So what is common to each of these terms? Cosecant x. So I take that out, I'm left with 1 minus secant squared x. How does this help us? This is one of your best friends. It would be equal to what? Just curious if you guys know. Negative tangent squared x. All right. Let's do a real problem. Verify. So, remember we only changed the left-hand side. So, we're on this side. Yep. We got this. So, let's go with Ben. What's the GCF of this guy? Yeah, so I'm going to factor out a sine x. And if I take out a sine x, Fabio, what's left? Way to go. All right, that should look familiar. 1 minus cos squared sine x. And you're like, oh, I should look at my best friends. And so you do. You go back up here at this top one. And 1 minus cosine squared x, patent b is equal to what? Good. It is equal to sine squared x, and then those multiply to give me sine cubed x, which is what we wanted to get. Okay. And example 2, we are going to factor tractor the top. This is not one of your best friends until you get powers of 2, so it's powers of 4, but it's still just a difference of squares. So Colin, can you tell me how to factor this? Good job. Exactly. And then it's all over secant squared theta plus tangent squared theta. And I ran out of room, you guys. There's still this plus, I'm going to squeeze it in right here, tan theta. All right, so we did that. So Stella, what cancels now that I factored that? Yeah, isn't that nice? That cancels. So what do I have left? Well, I have secant squared, there should be a theta here, theta minus tangent squared theta, and then I still have the plus tangent squared theta. So that's nice. We don't have to look for one of our best friends right here because something else cancels. Evan, what else cancels? I have a negative tangent squared and a positive tangent squared. So I'm left with secant squared theta, and that is what we were trying to get on the right-hand side. Let's try another one. All right, so I'm probably going to multiply those. I think it makes sense to switch the cosecant to 1 over sine and just see what happens. So I'm going to make this a 1 over sine x. And I'm going to multiply it by sine x minus, I guess I'll make this 1 over sine x too. Okay. So when we multiply these, this is over 1. So I'm multiplying 1 times sine and sine times 1. So I get a sine x over a sine x. Okay. And then I'm distributing top to top. That's 1 times 1, which is 1. And in the bottom, sine x times sine x, which is sine squared x. And Harrison, what should I do next? Ooh, I bet that would work. We probably could do that. Or we could make this 1 minus cosecant squared x. That's how my brain sees it, okay? But I think it works probably the way you're thinking too. And this is one of your best friends. Let's see. What am I trying to find? 1 minus cosecant x. So what is that equal to? Negative cotangent x, which is exactly what we were trying to find. Yay. You're good? We should do this one. All right, you guys, this is cubes. So in the top, we have to do the formula for cubes again. This is sine cubed alpha minus cosine cubed alpha. So remember, the format is 2 terms, 3 terms, right? And so in the front here, Thomas L., what should I put? Good. Okay, and then we follow the pattern. It's the first thing squared. So Anna M, what goes here? Good. And then it's a plus, and we multiply them together. So Kelsey, what goes in the middle? Yep. I'm running out of room. Should have made my parentheses a little bigger. Plus the last thing squared. So cosine squared alpha all over sine alpha minus cosine alpha. Cool. So Jake, what cancels? Ooh, that's a nice thought. What does that equal to? Right, so that doesn't cancel, but that is equal to 1, which I'm going to change here in a moment. Okay, what else can we cancel, Hannah? Yep, that would be lovely. And now I'm going to rewrite this. This becomes positive 1 plus sine alpha cosine alpha. And that's exactly what we were trying to get. You guys want to do some whiteboards?